p.m. in the library. And now it's time for your Friday raffle.
What the heck's going on back there, Gets? No makeup breaks. What are you trying to look good for? Put the thing back on. Miss Kirkland, you're trying to start trouble in my classroom? That's not okay. By the way, it's been recorded for later. All right, moving on. Yes, we need evidence. We got it. No, I'm recording it using Screencast-O-Matic.
I know, but do all smartboards have that?
It's a separate program. Actually, two of the fanciest two boards in the room in the school have them. Miss Hendy's does, and Mr. Manning.
Why do they get the fancy ones?
They're the first ones that got them, and they get fancy ones because they really wanted them. And I said, please don't put one on my board. Please don't put one on my wall. I need my whiteboard. And look, it's here.
Do you like
That's
it,
what you
or do
wanted.
But the district's running out of money.
Take it back and sell it.
And then the other thing I have, you guys don't know this yet. This is really cool. I've got this too. Are you ready? Ready?
What is that?
Because you guys have trouble hearing me from time to time. I can talk into this and you can hear me in outer space.
Leslie, use that from now on. Leslie, for the rest of the class today. Leslie, use that thing for the rest of the class today. Please. Please. Sort of doze off. Well, I'm wait. First off, I'll offer lunch. Second, I'll do you have a difficult
Do you have the lanyard?
That's a recipe.
Yes, I have a lanyard version in case I want to walk around and talk like that. Okay, now we've been the first 2 minutes of this thing doing nothing. Let's do a problem, shall we?
What? Microphone for the rest of the class today.
No.
Why not?
No.
Why not?
It makes me angry every time I see it, except on Saturdays when I bring the building down.
We can't hear you.
Oh, I turn it down and the windows start shaking. It's great. I can be down there making copies and hear it. All right, now we've burned 2.5 minutes. Let's do a problem here. So I look at this, and it is a minus sign, so it's a hyperbola. It's a hyperbola, so therefore I got all the information I need to go ahead and graph this thing, so I'm going to go ahead and do that right away.
Wait, if it's a plus sign,
It's an ellipse. An ellipse,
which is a circle.
which is an egg-shaped thing. We wouldn't call it a circle because a circle has equal semi-major and major axes. All right. So I take a look at this and I go, I'm going to go 3 up and 2 to the left. So 1, 2 to the left, 1, 2, 3. There's my center. Agreed? Everybody should be able to agree with that. Everybody with me so far? Then you're going to say, okay, now, which way do I open? Now I'm going to give you the easy way to do that, right? Nope, I'm not going to because it needs to raise it down. Yes?
Yes. Okay.
I marked you absent. Where were you hiding? You went to the bathroom? At the start of class? That's a problem. All right, moving on. So I got a 1 here. It's underneath the Y. So I'm going to go up, because it's Y, I'm going to go up and down 1. So I'm going to go 1 here and 1 here. Those are where the 2 points are that touch. That's my 2 vertices, right, as I'm drawing my hyperbola. Okay, so far so good? Then I look at this and go, all right, so now I need to have some guidance to how to draw how fat or skinny my hyperbola is. So I'm going to find the slope of the slant asymptotes. Yeah, that's what I say too. So what's the slope? The slope is B over A, right? So B is 1, A is 3. It's plus or minus. So B over A. B, what's underneath the Y, divided by what's underneath X. Because rise over run. Y is rise, X is run. Oh, it's the square root, right? I mean, it's A squared and B squared, right? This is also the square root of 1, which happens to be 1. Fair enough?
Yes.
Okay, so now it was plus or minus 1/3. I'm going to go up 1 over 3, up 1 over 3, just like you learned in those classes a long time ago. And I'm going to draw a little dashy line like that. And then we do the same thing for negative. So down 1 over 3, down 1 over 3, and I'm going to go wee.
Start with the center.
Through the center point, yes. Through the center point.
They're always running out. Like they're really bad when I go up.
You got me whiteboard markers? I was kidding. I was totally kidding. Oh, you got a gift card. Okay, good. I was totally kidding. No, you shouldn't know. That's totally silly.
I didn't
Okay.
get serious. So that's funny.
That was, okay, good.
Really silly.
You got me a hat already. I'm set for life.
Yeah, should be.
That hat's going to be here like until they wheel me out of here. I'll use it to cover my face. All right. Here I've got a point. These are asymptotes. I'm going to approach them but not reach them.
That's not.
Approach
How do you know
them,
if it's from the side
but
or
not
up
reach
and down?
them. What?
How do you know if it's from the side or up and down
Because this 1 is underneath y. It's the 1 in front of the minus sign, right? 1 in front of the minus sign guides up and down from the center.
Y minus X is
So y minus x is going to be up, down.
and
X minus y is left, right. But if you just think about it, this is underneath the y, right? So this is a b, like we've been doing all along. So I'm going to go up 1 from the center, down 1 from the center, because it's b. Put my dots in,
okay.
and then I can draw my. Yes.
What would it be if it was like negative y minus 3 over 1 minus x plus 2?
A negative, I would then, oh, that's an interesting question, because my temptation would be to say that I would multiply both sides by a negative, which would give me a negative over here. It would give me an imaginary hyperbola, and I'm not sure what that would look like.
Okay.
I imagine, put it this way, I'd have something squared plus something squared equals a negative number when I move the negative to the other side. What could make that happen?
Imaginary numbers.
And something really not normal graphed.
Okay.
Yes?
To clarify, if it's x minus y, then it's going to be sideways, right? Okay. If it's y
But-
minus x.
What I was saying, and I think this is really the better way to learn it. You ready with me?
Yes.
I found my center. We don't have trouble with that at all. Now I gotta find my points. And normally way back when we did x and y, right? We found our a's and our b's, right? I'm gonna start with what's under here, right? Which is underneath the y, right? So it makes this a b, right? And so the square root of 1 is 1. So I'm gonna go, because it's in the y direction, it's gonna go up 1, down 1. Those are my 2 dots.
So,
Once I have the 2 dots, I know which way it opens.
so if x is in front, does that mean?
If x is in front, this is gonna be an a, and I'm gonna put the 2 dots left and right.
So would you take the first term, you take
As long as you wrote it as this minus this, that should work every time.
always take the first term.
Yeah.
Okay. And then it's square root
I
that.
just think that's the easiest way to do it.
So if it's an x, then it's going to be
Right, because it'd be the number underneath the x that you'd be focused on, and that you should look for it. Okay, so far good then?
So
Russ, he's not actually gonna watch this. You know he won't.
Hey Brian. Hey,
He's the one that
Brian.
requested it. He might watch it.
Hey, press.
Hey
Hi,
Brian.
Press.
Is that press?
Hey Brian.
Okay.
Okay? So then 36 divided by 900, I think about it really hard, and I realize, oh, that's just got to be 25.
Oh yeah.
Minus, and then how many times 25 going to 900? Well, that's 4. 25 is per 100. 4 times 9 is 36. That's got to be 36.
Oh, yeah.
Y squared equals 1. And then I got to graph this, so I start looking at it. I go, it's graph paper out, because I like graph paper. Makes me happy. What?
Just keep doing it.
He's gonna do it for sure.
I'm going to do what? Wow, that's not going well. Nothing's going well. All right, whatever. So where's the center?
0, 0.
0, 0. So it's right there in the center. Now I'm going to go which way?
Left and right.
Left and right, how far? How do you know it's left and right? It's X, right? So we go 5 to the left. Then I'm going to figure out what the slope of the slant asymptotes are. Formula for that is m equals plus or minus b over a. Now b always refers to y, right?
Yeah.
So what's the square root of 36? 6. What's the square root of 25? 5. So this is going to have a slant asymptote with a slope of 6/5. Yes, sir.
It's always b over a or
It's always B over A. But B always is the one that's underneath the Y. Okay? So rise of 6, run of 5. And then how do I draw my hyperbola? Like this, approaching that but never reaching it. Like this, approaching it but never reaching it. Like this, approaching it but never reaching it. Like this, approaching it but never reaching it. Ta-da! Done. Yes?
Can you explain your relation to the hyperbola you used in the last worksheet where it's like X?
There's almost no relation at all.
Well, this is some form of division in half.
That's not really, oddly enough. Not really. I will say the following observation for you to, no, I'm not. No, nothing. There's no comparison, nothing. No way they're the same. Surprised you think they look the same. We call them the same thing because of a historical accident. I made that up. No idea. Are we good?
No.
To the next one.